Hello.
Hello.
How are you all doing?
Good. And yourself?
Fine, thank you. So I think we can start since it's already 3:05, 5 minutes after 3. Today we'll be working on the data description. I know that I'm sure that you checked my announcement for the work that I do this week. Let me take care of some few things. I think I opened so many pages. Let me close some of them so that we can begin. Yeah, I think let me close this one. Okay, good. So I believe you saw the assignment, my announcement about the assignment that are due. Those assignments, one of them is the one that was due yesterday, but I extended it to next Sunday because of the issues you guys were having with it. I think I uploaded the wrong document there. So it was giving you, well, it was taking you to a different website when you click on it. So I have fixed the problem so that you can now do it this week. Then we have our regular homework that is due in Piazza, my lab, and we go from there. Now, you can see my screen, right? I believe. Hello.
Yeah.
Okay.
Yes.
Okay, good. Now, today we'll be looking at data description. When we talk about data description in statistics, we're talking about those statistics that we use to statistics that we use to describe a population. Now, remember, the population is not only human beings. It can be number of cars manufactured in a year. It can be number of gas stations in Baltimore City, and so on and so forth. So those statistics we use to describe the characteristics of this population, that's what we'll be looking at this week. And actually this week and next week, because we continue next week. So your homework this week is based on one we'll cover this week. Now, we'll start with the measures of central tendency. Make it bigger. The measures of central tendency. The measures of central tendency, they are so called because we use them to describe the center point of a data set or distribution. Those measures include the mean, okay, the mean, the median, and mode, and mid-range. Now, so these are those measures we use to describe the center point of a distribution. Now, the mean simply means the average of a distribution. Oh, by the way, I uploaded a handout for you that will cover this section. Handout 2, I believe. So you can download it in from the file section of this cost share. So the mean is the average of the distribution or data sets. So we find it by adding all of them and dividing by the count. The median simply means the middle value with half of the data above and half below. Basically, the value at the middle. So for the mean, you can say the average age, of all the students attending this class at Morgan State University, or the average, let's say average speed, things like that, are the mean. The median is, like I said, the value at the middle with half of the data set above and half below it. Now, usually we use the median to describe, income, because mean can overstate income. So median is better for describing income. For example, when we say that the median income of college professors is 65,000 a year, that means half of them make 65,000 a year or more, and the other half makes 65,000 a year or less. Mode is the value that occurs most often. Examples, we can say let me apply this to real life situation. For example, the way we talk about the stock that sells most in the stock market. I think Amazon stock is selling so fast. Well, I mean, the price is going up and it's very, very high. So I would say that it is one of the most preferred stock. That's the one, because it is when people keep buying it, more of it starts going up more. So the most preferred stock might be the mode is Amazon. Of course, we can have more than one mode, because there are other stocks that are that are very popular, like Google stock, Apple, so on. So we can have more than one mode. Now, when it's more than one mode, we call it let me see. Let's say bimodal, unimodal. Modal means for one mode. One mode. But when it is two modes, like two most popular stock, you can say bimodal is for two modes. One is more than that, you call it multimodal. More than two modes. How about this? We can say the most preferred model of washing machine. That is the mode. So if I forgot the names of washing machine, okay, the most preferred cell phone, I would say Apple. Am I right or wrong? Hello?
Right.
Yeah, because among the smartphones, Apple is very popular, Then the most popular presidential candidates, well, this time it was Biden. Before it was Trump, because he won in 2016. So he got the mode among all the candidates. But this time around, Biden won, so he became the mode. So that's how you can figure out related to real life situation. So when statistics, number that occurs most often becomes the mode. So now we're going to look at how to calculate these values. Okay, before I do that, we need also the mid-range. This is the rough estimate of the middle value. Usually you get the mid-range by adding this the largest value and the smallest value, and dividing the result by 2. That will give us the mid-range. So almost similar to the way we interpret the median. So simply stated, the mid-range becomes the maximum value, minimum value plus maximum value divided by 2. That gives you the mid-range. So we're going to come across this. We'll be looking. We're going to look at how to calculate these values for on-group data. How to estimate mean, median, and mode for on-group data. Okay, let us take these examples. Perhaps we'll be focusing on mean and median today. Okay, good. Okay, let me make this bigger for you so you can see it better. Okay. So first one example is this. A sample of 15 overdue accounts in a large department store yield the following results. You can see the result: $55.20, $18.06, and so on and so forth. It says determine the mean amount due for the 15 accounts sampled. That's the average, mean the average. Then it says if there are a total of 150 overdue accounts, use the sample mean to predict the total amount overdue for all 150 accounts. Now, if you want to calculate the median or any of these measures, the first thing you should know is their formula. They all have a formula. And one thing with statistics is that one of these measures can have up to two or three different formulas for finding it. So I recommend that you stick to the one we use in class here so that you don't get confused. Now, even though they might have up to 3 different formulas for finding them, now, but your answer will still be the same at the end of the day. So that's why either or, if you're more comfortable with the formula that is in the handout that I uploaded for you in file section in Canvas, use that. But they are, as a matter of fact, they are even similar to the one I'll be using. Okay. So now, solution. Let me write the formula down. Okay. The formula for finding the mean is, but this is, remember, this is for on-group data. The formula for finding the mean for group data is different. We'll come to that probably next week. Now, so to write the formula down, I'm gonna take you to the other workbook since this session won't let me put the formula, the way it should look. So let me take you to this other workbook. The mean is, okay, the symbol for the mean is X bar. So we got X bar. 1 minute, let me pull this out. X bar. Okay. X bar is for the sample mean. Throughout this class, we're dealing with samples, not the actual population. So we're using S bar for the mean. There's another symbol for the mean, mu. So I'm going to show you both of them. X bar equals a summation of let me put this symbol right. Sum of X divided by n, which means sum of x1, excuse me, x1 let me yeah, this should be it right there. Sum of x over n. Okay, here you go right here. See? So listen, look at this right here. So these are the S. This one is x1. This first number here is x1. The second number is x2. See? And so on and so forth. All the last one, which is x15. So Sum of X means to add all of them, and it represents number of items here. So this symbol here is the Greek for, we call it sigma, which means the sum of. I mean, it's to add all the x's. And these are all the x's right here. Then n means how many of them? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See? So sum of F over n, that's the mean. So where this symbol here, x bar, represent the mean, this symbol is sigma, means sum of. And x represent all these numbers here, and n represent 15, which is how many of them. So taking you back to the workbook. Before I do that, I want to write this down so we can make it easy for us. So some of all of them, let me write some of them down. $55, 20 cents, $18, 6 cents, all the way to the last one. And the last one is $82.73. $82.73 over. Now, how many of them? You have 15 of them, about 15. Okay. So we have it here that let us do it. Taking you to the other workbook before we can transfer this to the main workbook. This means that we have to add everything. Let me get it down here. 55.20 plus. Next one is $8.06, $18.06. 6 cents plus dot. I mean, you keep adding until the last example number there, which is $82.73. Then divided by all the items, which is 15. So I did this already, actually, in I did it already in my book. So I'm gonna put the answers here so you can see what is it. Yeah. What I got. I got $165.57. Excuse me. Let me put it the way I want it to look so you can see what I mean. I added all of this. All of this right here, according to what the formula said. So that when I added it, and then I got this answer, and then which I divided by 15, the answer I got was, I don't know why this is doing this equation. Okay. So it wouldn't let me put it here. Okay, I think I have to start this because this thing will let me put the answer. Equals okay, let me try it this way. Stretch. Okay, we're back. So let me put it back again. So we have $55, 20 cents plus $18, 6 cents plus dot means that it continues to the last one plus $82.73 divided by 15 of them. So when I did this, I got this answer, which is after adding all of this, and divide by 15. I got the answer $165.57. 57 cents. So I'm gonna take it to our main workbook so you can see the results there. So this is it. So the average question we're asking for the average. So the average or the mean amount due for the 15 accounts is $165.57. So that's how you interpret it. Explanation. Okay. It says the mean amount due for the 15 accounts. The mean amount or average amount due for the 15 accounts is $165.07. Any question for me?
So just to be sure, we put the dots so we don't have to write in all the other numbers.
Yeah, because if you want to write all of them, this place will not be enough for it.
Oh, okay.
Yeah, so I just this that to show that you're adding everything here.
Oh, okay.
The last one of them is $82.73. That means this one right here. Okay. Any other question for me? Okay, good. So this is remember this is for on-group data. Now for group data, we're gonna use a different formula. We talk about that when we come to that probably next week. Now the part B says if there is a total of 150 overdue accounts, use the sample mean to predict the total amount overdue for all 150 accounts. So that's part B. Part B, total amount overdue equals the average amount, which is 165.57 times all the 15 accounts. Sorry, I think it's 150, right? It's 150 accounts. All the 150 accounts. Now, this we can get from our calculator, Desmos. Remember, I told you we have this free online calculator we can use 150. So let us go there and then find this product. So I'm taking you to Desmos now. So remember, it's free. Desmos.com have 165.7 times 150. That gives us 24,835.5. Let me take you back then to where we are. So we got 24,835.5. Now, you can see why if let's say that your energy company, even if you're owing them $5, they will still send you the bill, because if 100,000 customers, this is only for 150 accounts. Now, if 100,000 customers are owing $5, that is $500,000 right there. So they will still send you the bill. Yeah. So when they make this kind of estimate, although of course once they the way they are, all these things have already embedded in their computer. So when it will just show them how many people are owing, average amount owed, total amount uncollected. Yeah. So they will not need to start calculating this the way we are doing it here, but it is what was done and fixed into their system. Yeah. Now, with that, we have seen the mean. This is giving us an example of how to find the mean. Next thing is the median and the mode. Like I said, the median is the middle value. The mode is one that is most popular, that occurred most often. So The median, to find the median and mode for on-group data, all you have to do is to, for the median, the first thing to do is to arrange them in order. Okay, let's see. Then after that, you can pick out the median or the mode. Let's look at this example here. It says, an experiment was conducted to measure the effectiveness of a new procedure for pruning grapes. Each of the 13 workers sampled was assigned a task of pruning an acre of grapes. The productivity measured in work hour per acre is recorded here. You can see right there. Determine the median and the mode, and then explain your results. Now, the first thing you do again is to put them in order, which I have done already. They're now in order. So for the median, this is where this solution started. For the median, you pick the number at the middle. Median here equals. You can see that there are 13 of them. So half of them should be 1, 2, 3, 4, 5, 6. This is the median right here. This number are the middle. Because this we have 1, 2, 3, 4, 5, 6. On the other side, they have 1, 2, 3, 4, 5, 6. So median is 4.5 worker hour per, worker hour per acre. So what does this mean in explanation? Okay, it means that half of these employees have but this is how many time the productivity. Okay, the productivity okay, let me put it this way. Half of the employees, workers, have productivity of 4.5 worker hours. I'm put it hours per acre or less. While the other half okay, productivity of 4.5 hours per acre or more. No, you know that journalists can write big article using this, but we, like I said, we statisticians and economists, we just give you what it is. Now the decision is all yours, or more. Now, remember, this is an odd number distribution. There are 13 of them, so it was easy to pick up the median at the middle. Sometimes we might have a distribution that is not like that. Let me show you an example of that. So if that occurs, what you're gonna do is this. Suppose I press this here. So suppose that the distribution is not odd, but it is even numbered. Let's say 12. In that case, the it's gonna be. Give me 1 minute. Take care of this. Okay. Now let's say that we remove one of these numbers here. It is now 12 of them. Now this is not part of the equation. This is just to show you if you have an even number distribution. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in that case, we have 5 numbers on the left, 1, 2, 3, 4, 5. And 5 numbers to the right, 1, 2, 3, 4. So 2 numbers are at the middle. You can see that 2 numbers are at the middle. And those 2 numbers are these 2 Okay. Two numbers. So you can have 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5. See, in that case, the median will be the sum of these two. So to find the median, what we're gonna do is this. You will do median becomes 4.4 plus 4.5 divided by 2. That will give you the median. So going to Desmos, you can get this from Desmos. We'll have take you there. So we'll have as the median becomes 4.4 plus 4.5 divided by 2. Give us 4.445. So 4.45. That becomes your median if it is an even numbered data set or distribution. 4.45. Questions?
No.
Very good. Now, let's say, because the question says determine the median and the mode. Now, for this, our example, remember, it is already arranged in order, okay? So that we have that the mode per our explanation is a number that have the highest frequency. So we have 4 has the highest occur most often here. As you can see, 4 occurred most often here. But we also have 4.8, 4.4 occurred most often. But we also have that 4.8 also occurred an equal amount of time. So that means we have 2 modes. The mode equals 4.4 hours per acre and 4.8 hours. So this means that it is bimodal. 2 modes. Now you can interpret this that most of the workers have the productivity of 4.4 hours per acre and 4.8 hours per acre, things like that. So that answered the equation for the mean. So far we have touched mean, median, and mode. Let us quickly take a look at mid-range. Remember, the mid-range is the rough estimate of the middle value, and this is the formula for it right there. Let's see an example on that. It says here that in the last 2 winter seasons, the city of Baltimore reported this number of waterline breaks per month. Find the mid-range. Yeah. Solution. So the formula for the mid-range is mid-range equals minimum value plus maximum value divided by 2. So the mid-range here, example, becomes the minimum value there is 1, and the maximum value is 8 divided by 2. And that will give us 8, 1 plus 8 divided by 2 means 9 divided by 2. It means 9 divided by 2, which is 4.5. Now, it depends on how to interpret this. That's why sometimes we say that sometimes you can massage statistics. You can lie with statistics sometimes. Now, a journalist who is trying to say that the city of Baltimore is experiencing higher occurrence of waterline breaks can say that the city of Baltimore last winter month they have at least, or they have 4.5 waterline breaks or more. See, but if you are trying to say that, oh, they're not having compared to Texas or maybe compared to other places, they don't have anything. They say that they only have, see, they use that adjective, only had 4.5 or less waterline break. Or they can say the way the popular way they press say that they don't have up to 4.5 waterline breaks in last winter compared to the previous winter, you know, or this winter. So that means it is sometimes depend on whoever is making the reporting the statistics. Now, like I said, we the statisticians, what we do is we give you the data the way it is. They show you the implication. Then it's up to you how to use it. Any question for me?
No question.
So now we're going to look at the measures of variation. The measures of variation. Now we look at those measures. I'll introduce them so that probably on Wednesday we'll start working on those. The measures of variation, we use them to describe how far away a data value have strayed from the distribution or from the mean, usually from the mean. Now, I'll give you a little explanation of what I'll use an analogy to explain to you what I mean by that. Let's say that the speed limit on a road is 45 miles an hour. Let's assume that is the average speed limit. Now, if you're going 50 miles per hour. So you are only 5 miles per hour away from the mean. Maybe the cops might see you and say, you don't have time for this, especially if they have something more serious to take care of. Now, if you're going 60 miles per hour in a road that is supposed to be 45 miles per hour, that will attract the attention of the cops. So those kind of, or if you're going 20 miles an hour in a road that is supposed to be 50 miles an hour, again, you'll be slowing down the traffic. That will also attract the cops. So those variations, those measures that tell us how far away our data value have strayed away from the mean or from the center. Those are what we call the measures of variation. So we are going to look into these measures. Let me introduce the first one, which is, I will introduce them. First one is the range, which is the easiest one to calculate. But you know what? Let us have this on Wednesday, because I want to show you something more. How to find the mean, median, and mode using Excel. So let us leave the measures of variation alone for now. We'll do it on Wednesday. Let me show you how to calculate these measures of central tendency using Excel. So I'm going to take you to Excel now. It's right here. I've already put those numbers in. This is the first one we have. So the mean. So suppose you want to find the mean of this data set. The mean. Okay, let me make it bigger so that probably you can. Okay, let me see. No. Make sure you can see this. Yeah. Make it bigger, a little bit bigger. Okay. Okay, got it. Now I can see it better now. So the mean. Now, before you calculate any of these measures, make sure that you put the Excel file or the cell in a ready mode. by putting equal sign, equal. So the mean is the average. So type in average. Once you put the equal sign, type in average. As soon as it shows up here, double click on it, it comes up. Then you can copy all of this. See? You can then close the parentheses. You can see, copy all these numbers here. Once you put it this way and then press the enter key, that will give you the mean right away. See? Now you can, you can format the cell. This is where you can change this to dollar sign. Click on that, you become a dollar sign. And then you can, highlight it. So if I see how Excel make it easy. Now, if I'm grading, if I ask you to do this as an assignment, if I'm grading it, I'll click on your answer right here, and I will see the work that you did. I'll give you a credit. Now, if you didn't do any work, if you just type in the answer, 165.57, when I'm grading it, click on this, it won't show me any work done. That way, that means you can get credit for it. Questions? Hello, class. Any question for me?
No.
Okay. Now, let's look at the median and mode. So let me add more cells here, so we can have more room. Good. So the median, we have median, we have mode. Again, the same process. Equals median, type median. Once you put it, it will show up. MED. So you double click on that, and then go from here. All the numbers in that cell. Oops, excuse me. Then close it. Press the enter key. It will give you the median right away. Again, the mode, same thing. Equal mode. This this is mode, right? I think it should be this one. Oh, excuse me. This one, it remains for the available to compatibility access. The earlier returns the frequency most. Hey, that's right here. That's the mode right there. So highlight this now because it has two modes. I don't know how the Excel will put it, but let's see. You give us one of them, 4.4. That's one thing with Excel. So sometimes it will give you something different, but you know that we have two modes. Yeah. Anyway, you get the point. This is what I wanted to show you.
So does any excuse me, Professor, is any so both of the modes work for it instead of the mode with the SGL, I think the other one? They both work.
This one is let me show you. See, look. Oh, this one is if it has multimodal. I think I use this one. See, it says returns vertical array of most frequently occurring or repetitive values in an array. Let's try this one. That's what you're asking me, right?
For homework, I think it said the second one with the SNGL.
Yeah.
That one.
Let's see this one. If this one will bring both of them out. So sometimes it might vary with the version of Excel you are using. Okay, close it. See, you give us the same one of them.
Okay.
So let us try that one. One I was about to show you.
Okay.
Mode. Excuse me. Mode. Excel has some limitations. I'll give you an example. When we start doing a test of hypothesis, Excel does not have a command for one sample hypothesis z-test, one sample z-test. So there's a way we trick Excel using two sample z-test. Then after that, I made some adjustments, to trick it, and then it will do the one sample test. So it has some limitations. And let's see if this one works. I want to type. This is the multi. See, I'm suspecting that this one will be multi-mode. Let's see if this we can give us the two numbers. Okay, but I doubt it. I will tell you. So usually if there's multiple modes, I do it the old-fashioned way. All right. See, he gave me the two numbers. Can you see it?
Yes.
Yeah, can you see it? So if you have something that have multiple modes, to give you two numbers, I'm surprised, really. Tell you the truth. So now you can see it. How to if it is multi-mode. Yeah. So any other question before we round up? Hello, class. Any other question for me?
No.
Okay, so I'm gonna end up today, and I'll see you on Wednesday. Please continue working on your homework online, okay? And then Excel.
Okay. Have a good
Bye.
Bye. See you on Wednesday. Okay.